There's lots of people here. Some are going to be comfortable coding, some of them aren't. So what I've tried to do is I've tried to set up this repo so that people can kind of get off the ground and kind of get running. So what I'm going to do is I'm going to show a quick tutorial on how you can actually do coding inside of GitHub. And then you can actually start learning how to parse the files, and then so on. So just to show everyone, I've set up a getting started here. So this is part of the repo. I tend to do all of my development inside of Python. So as a result, the examples that I provide are using Python. And so I tried to provide a general understanding of the big structure. As Dan said, he will provide a more comprehensive discussion as you all start to dig through it. I'm going to be constantly modifying this repo. So I want it to be set up so that you all can kind of run things and be able to start. Okay, so to show people how, from this repo, you can go down to code, and then you can start up a virtual machine from this repo. So right from here, if I hit the plus, this will set up a computer for you to start cranking on. So right now, I've already set one up, and the way that this will set up all of the packages that you'll need to then run the example scripts. Just to check, does anyone have any questions so far? Awesome. Okay. Yeah.
Hey
Yeah.
Ross, I'm,
So
I'm just curious of the teams. Maybe they could just mention,
that would be awesome.
does
Yeah,
does anybody have experience coding or what your level of experience might be?
that would be super helpful. Yeah. So if we can have a few chime in, maybe one from each of the teams.
I guess I have a lot of experience with data analytics, just using Python, but I haven't
Beautiful.
really I haven't deployed like any applications or anything like that.
Okay.
Yep, even I have an experience of coding like in the data science and engineer background. So
Okay. So do we have two teams on this call, or do we have more than two?
No, I think my in my team we have also experience in Python and C++ and
Okay.
programming in general.
Awesome.
Me also Python and maybe some web development things, CBSS and JavaScript.
Great. Awesome. Excellent. Well, it sounds like everyone so far has a pretty good foundation. Yeah. So hopefully the GitHub should be set up to kind of show you the fundamentals of how do I parse a file, and how do I basically load it into a data frame? Maybe it would be helpful for us to maybe have a understanding of what you guys are thinking of trying to achieve. Maybe we can also go one at a time through the teams.
Yeah, I guess the question is, do you have a big picture idea of what you want to try to develop, or do you have questions about types of things that can be developed, or how to use DIGGS? We're happy to share ideas or help expand your ideas if you'd like.
Yep. So I can start calling on the individual teams if that is helpful.
Yeah, we were we were started something. My student Samantha, we have another student in our team. So initially actually we were learning, the XML format and trying to, it was not validating. So I think now we are able to validate the file. So now we are trying to take some sample boring PDF and trying to convert it to XML and to extract the information. Like as we are based in New York, so our goal is on the New York board logs. So I think my students was having some difficulties, so he can talk with more technical. It is actually what he was actually getting the error. Samantha, if you can share your experience.
Sure,
That's
thank
great.
you.
We've got a couple people on the call that have been
Yeah.
working with PDFs and conversions. So between Scott
So,
and
like,
Ross, there's a lot of experience there.
I also, I implemented a stage one DIGGS 2.6 XML validator that behaves like very similarly to the validation engine used in GeoZeta. So I used here the LXML library as the validator engine since it appears to match GeoZeta's behavior. I feel like that. And I've worked on official DIGGS 2.6 schema and also 2.5.a. I got a challenge like a global declaration in geophysics, so I applied minimal non-disruptive placeholder, so it worked fine. And now that it is running locally, it's very good. Like the XML validation, I can able to pass the XML file and validate into the DIGGS exist schema. Now for the hackathon, I'm particularly interested in working on a file to DIGGS XML conversion tool, especially like focused on PDF and CSV inputs. Like in real geotechnical workflows, most bore logs and lab reports and site navigation data like still lives in PDF. So I just want to build a PDF or CSV to DIGGS XML converter with a clean user interface tool. So I have few questions on this, like what is the typical workflow like used by GeoZeta or other departments to convert a raw data into DIGGS XML format? First thing, so, and what are the minimum required elements one must extract to form a valid DIGGS root structure? And also, which DIGGS components are most common or most important to include, like sampling feature or lab test or boring? I have this one, and I also like have what I've developed the tool XML validator. Like as we uh, going to release the version 3.0 this week, so will it be any problem or any? Do I need to make any structural or architectural changes to the validation part? To the old version 2.6. So these are my questions.
That's really good questions. Maybe I'm going to save some of those till the next time because I think we're going to need more time to answer them about the 3.0 change. But I want us to address that next time. Yeah. So
Sure, no
awesome.
problem. Thank you.
All right. Let's see. So far, we've heard from 2 teams. So I'd like to hear from the other teams that are here.
I don't know. Let's see. So, I mean, I definitely want to do more with like MWD data and like deep foundation testing data because I know kind of a lot of that data, especially if it's old data sets, is kind of hard to upload. And then I guess if you had a way of you know, just easily parsing that from a PDF onto a platform that has, you know, data analytics where you can look region by region, and just see kind of what the site conditions are like, and see also as-built data. I don't know if something similar to that kind of already exists, but I don't know. I gotta brainstorm some more, I suppose.
Awesome.
I just thought I'd
Sorry.
mention that with respect to deep foundation data and MWD, both of those capabilities we're reaching into those with the version 3 updates, and they haven't really been flexed very much. With respect to piling data, we do have a structure for handling, you know, pile driving records in PDA driving records, not post installation testing yet. So we don't have any structures for that. MWD, we do have a pretty extensive dictionary of measured properties. So that should be pretty well ready to go. But I just thought I'd warn you a little bit about piling, is that we're not kind of all the way. We don't do cast in place. We don't have post installation testing capability yet, but we do think we've got a structure that's pretty well set up to work with driving records and PDA records.
I will tell you, I encourage you to push on it. So if you have files that you would like to try to figure out how to put them into DIGGS, please don't decide not to do it because we haven't properly put it in place. I want you to push on it. Yeah.
Right. So that's the thing, is this would be really good to exercise what we have and to see where things may be missing. And as long as we're not entirely breaking existing stuff, we can push out another release pretty quick to accommodate that stuff.
Okay, I think that sounds good. So you said you're you have it for you're gonna ready to roll it out for the driving records
for driving records, and also for the basic PDA data, you know, as you're driving. But
Alrighty,
like I said, the PDA analysis, no, and the post installation testing, you know, no, we don't have those test structures built. Yeah, load tests and things like that are not in there yet.
Alrighty, I think I don't know if you have anything you could send me on that, but I guess that's kind of the other tricky aspect of it, is like what level of detail you want to go with it in terms of you know, taking the data from like the cap lab. So I don't know, maybe I just gotta.
Well, we can talk more specifically about that. I'll, you know, can point you to where that, I mean, if you can come to the DIGGS call tomorrow, we have a general call. I'm going to be talking more about where to find all the 3.0 stuff. We do have a pre-release up, but it's not advertised yet on GitHub, but it's in there. And to look at the schema documentation for what we have for piling, and you can see what level of detail is already there. We don't deal with raw instrumental data like voltages or anything. So anything that the basic information out of the instruments, like sort of driving rates and counts and blows and all that kind of stuff, are things that we manage.
All right, that's actually a really good point. I want to put in the fact that we are having a DIGGS call tomorrow so that everyone on this call can join. I went ahead and put that in chat. And if you guys want to drop in your email address, I can put you in as a future so that you see them. So feel free to drop them in. But that's actually a really good opportunity so that you can kind of hear those things sooner. And then it's kind of helpful so that we don't have to repeat them. So yeah, that would be great.
If I could add something to that, Ronan, I think you mentioned your family has a deep foundation or a foundation installation company. One of the challenges is always having data sets. And if your company has a couple of decent sized projects that you've got those records for, that would be a great starting point for running DIGGS through its phases.
Yeah. Exciting.
Yeah, and I could check with my family on that one, as if it would be useful if we could like maybe put together a bridge package of some example testing data.
Awesome. Okay, I think we still need to hear from at least one more team.
Hello. I think my team will be do some more simpler, just need some borehole data like it's and also CPT and CPT and SPT data to run soil liquefaction analysis. Since I think I will also use USGS provided API to get some seismic zone data and try to build a platform, maybe a website to connect the XML file so I can directly input some borehole log data. Then user can directly use the data to run liquefaction analysis and the shallow foundation analysis. I mean, for the stability analysis and also deep foundation. So far, I think I can. Oh, these three case study, not that case study, these three construction case analysis. So the data all I need, I think just borehole data to, and also the soil type for sure, like clearly soil or sandy soil to make sure it's undressed or generation. Yeah.
Excellent.
I like a good application, use
Yeah.
the data for something that way. It's good.
Yeah.
Thank you.
So feel free to reach out to me as you're going down this, because you're going to need to do a lot of JavaScript if you want to have this done in the website, unless you want to use a Python framework. So just know that I'm a resource and I would be happy to kind of talk through the best way to try to integrate it. Okay, so do we have any other teams? I don't believe so. Okay. All right, now I'm going to put Scott on the spot. And what I would like you to do, Scott, is to talk through the data sets just to kind of give people a general understanding of what they're going to see.
Okay. You're good at putting people on the spot.
Yeah, I
today.
know. I'm sorry.
All right. So, well, to start with, I've got 3 different data sets that are coming. They are real projects coming from Louisiana DOT. One is we're going to call a small project, one is a medium project, and one is a large project. The size of those DIGGS files, uncompressed, is somewhere between 10 megabytes for the small and 40 megabytes for the large. I think 30 megabytes for the medium size. So it's medium large, we'll say. So a couple hundred boreholes and CPT soundings with a variety of different lab testing. I think there's track seals, maybe some consolidation data. Obviously, index testing, out of our limits, moisture contents, grain size, sorts of properties should be in there. I have not personally reviewed this data. So if there are problems with the data, that's because whoever provided them to Louisiana DOT maybe didn't do proper QA/QC or something like that. So there definitely could be problems with the data. This was also data that was migrated originally from Ghent into Open Ground. So definitely there could be some weird stuff. It's coming from various contractors who I think we have removed all of their names, but there's probably at least 4 different consulting firms that worked on these projects. So you're getting a variety of different data from a variety of different sources, all in some good projects. Yeah, boreholes, CPT, lab testing data, pretty much the data sets we have there. I'm currently working with the Army Corps. They've given me the approval to convert maybe 5 other projects that are also in Louisiana. Apparently, we have a lot of stuff going on in Louisiana, so hopefully you'll find some exciting data there as well. I think they're all related to levee projects in the New Orleans area, probably, or somewhere close to New Orleans anyway. And for those, I believe it's similar data sets. They have more lab testing, but they also do have CPT. So I think that's pretty much it.
Perfect.
Just to
Thank you.
add to
Yeah.
that, we are still hoping and trying to get a data set from TxDOT, Texas. That's a tunnel project. And the hope with that is that we'll be able to associate the geotechnical data with the CAD or BIM model. So you would have both the data and some sort of a model of the project itself that you could tie the things together to. Or we
Scott, I
just
have a
need
question.
final approval on that.
Scott, I have a question. The files are organized by project? Is it?
Yes,
that correct?
each DIGGS file we are providing as an individual project. Yes.
As an individual project with however many boreholes, and all of the testing is all incorporated into one. That's why these files are pretty large. But I noticed
Yes.
the one you sent me was 170,000 lines, something like that. So yeah, okay. I'm just curious as to how they're organized. That's great.
Yeah, and that's the small one.
Oh, that's a small one. There you go.
Yeah, 10 megabytes of text is a lot of data.
A lot of data.
No matter how you split that. All right, so I want to now give a chance for Nick to kind of review the set that he's going to be dropping in the near future.
Yeah, so my goal is to take some of this example data and put it into a SQL database architecture in case people want to use it from there. I have built a tool. Let's see. Do you guys have links to that already, or should I put a link in chat?
You can put it in chat. That would be very helpful. And you can also feel free to update the repo for the challenge.
Alrighty, put that in chat. And what it is also is it's a executable file that you can download onto your PC. It has an Excel template that it generates, so you can go kind of through a life cycle of how consultants would use data, making it DIGGS compliant and importing in DIGGS compliant and using it with your own infrastructure. So that's one of the things I'm going to be providing. That's meant to have it done before this meeting, but hopefully it'll be done soon. And I intend
Excellent.
to use all the example data sets, make them into SQL databases as well.
Awesome. All right, so I want to make sure we get plenty of time for other people's questions or comments. I think for the next meeting, I'll probably do a short presentation on how to connect to the repo, how to run some Python scripts, just so that everyone kind of has that foundation. And it sounds like, Dan, you'll provide a more comprehensive review. Yeah, and I guess why don't I switch it over and see, does anyone have any questions or concerns? All right. Awesome. All right. Well, I'm super excited to see where we go from here. Yes. Yes.
Hey, Ross, Sumant had a couple of questions there, I believe. Some were related to version 3, but some are more general.
Okay.
Do we want to explore any of those to
Sure.
kind of help keep him moving along?
Yep. So what were some of those general questions? I don't recall.
Sumant, you want to remind us?
Yep, I can do. I can remind. Like, basically, as I'm planning to develop a user interface tool from PDF or CSV to XML conversion, so I just want to know about like how you or your team like work on like what's the typical workflow used by Ziozeta or other departments to convert
Oh,
the
sure. Yeah.
raw
I
data
can
into
totally
DIGGS
help you
XML.
on that. Yeah. All right. So there are scales of problems. All right. So if you have a very well-known structured PDF, that's a repeatable PDF structure, Something you can do is a programmatic approach. And the best way to visualize the programmatic approach is basically you can perform OCR, or you can also, well, before you perform OCR, you need to basically have your program find particular places in the well-structured PDF. So what do I mean by particular places? I'm saying you need to have it automatically find where you have certain columns at. And basically it's going to build a scale from the depth scale so that you can convert from the position on the page into the depth under the ground. So you can kind of think of that as needing to convert from the page scale to the depth scale. This is something that is, you can do this for if you have, say, 100 to 100,000 PDFs that will all have the same structure. This is something that you can programmatically achieve. And what's really cool is you can basically programmatically achieve it at around 95% accuracy. Same thing for a CSV. If you know that it's going to be a repeating CSV structure, you can easily convert that into the standard DIGGS structure. What becomes harder is if we think about the fundamental GINT file, they don't have a standard structure. So what a GINT file actually is it's a Microsoft Access database. And so the columns that you have, the column headers, that is all completely arbitrary. So that is going to be changing by company, that is going to be changing by office, and that will also be changing by engineer. So the complexity of that becomes a lot higher. So basically, the way that I solve that with GeoZeta is I've basically made routines that will parse through hundreds of thousands of GINT files, and it will basically generate one database from all of those separate structures. And it is then going to basically use machine learning to figure out what of those columns are the same and where are their duplicates, so on and so forth. And it then tries to generate a mapping file to go from the uniform structure that all of those separate files have been converted into, and then map that into DIGGS. So that is the medium difficulty. And then the harder difficulty is when you start to get into fine tuning visual to language models, so that you aren't having to do OCR at all. And you can basically take a photo of a boring log and reliably convert that into DIGGS. And it can be basically any random structure. And that is something that's quite a bit harder. So does that kind of help to talk through the range of the problem and the way that you can kind of solve it?
Okay. Like similarly, yes, yeah.
Hmm?
I'm sorry, like what did you ask me?
Oh, so I was wondering if that was kind of answering your question.
Yeah, like I'll work on that because I'm actually a data science student, so I need to explore about that board logs and sampling feature lab test data like of civil engineering data, and I'll work on that. Like I took few points from the workflow what you explained the medium, so I'll work on that and I'll come back with new questions on next week.
Great. Awesome. Awesome. All right. Let's see. Is there anything else that we needed to cover?
How about just a recap of the overall timeline and competition and such?
Oh yeah, sure. That's a great thing to do. All right, so everyone can read. I think I'm still sharing the screen. So if I go bit back to the main repo, um, all right, so if we go back to here and we go back to the hackathon, so everything is hopefully summarized here. So the competition, or not competition, I should say, the student hackathon um, has started, and so it will be stopping on March 9th. And then we're going to be having a ceremony in Geocongress. Um, yeah, and we'll be providing these weekly office hours to kind of help provide guidance. Yeah, and trying to think if there's anything else. Did you want to talk about the sponsor stuff, any Alan? Or
I guess the only main comment is Sequent, which is part of Bentley, is the main sponsor for this event. So they're supporting us, and um, I think they're happy to lend a hand as well if there's anything they can do to help move this along. But they're excited about being a part of this hackathon and integrating DIGGS into their tools as well.
awesome.
So we thank them
And
for that.
yeah.
And they'll be happy to spend time with you and catch up at the conference. They'll have a booth there, and I'm sure they'll be looking forward to chatting with you.
Yep.
I guess
yeah. Mm-hmm.
I just have one like side question. I guess with GeoSeta, so this is the first kind of time I'm seeing it. Have you guys had any experience like working with the board DM like APIs?
Yes.
Um,
So yes, for sure. Yep. Yep.
so
Yes.
is that all that is like is there any states where you have all of their geotech data?
Yeah, there's quite a few. So this is actually a good segue to show GeoSeta. So people that don't know about GeoSeta, as I said, we are a free tool where we are basically providing all of the public geotechnical data to the profession for no cost. As part of that, we are trying to convert all of their data into DIGGS. And so if I go back to the main page to answer your first question, these are all of the DOTs who are contributing data. And if I actually go into the mapping application here, as I zoom in, you'll see all of the points that GeoZeta contains. And what's kind of cool here is if I were to go into here, actually, let me find a spot in Virginia. And if I were to go into here, let's zoom in. All right, so you see all of this wonderful data that we have here. And I'm not signed in, of course. Sorry about that. All right, so after I've signed in, yep. Do that one more time. All right, let's go to a random place in Virginia. All right, so I can come into here and I can actually view this as a PDF. This is what was actually provided to us, which you can see it here. And basically the discussion that I just had, we built a tool that would automatically convert this into DIGGS. And we could do that because all of these have a similar structure. So if I go into here, they are generally having the same columns. They don't stay in the same place, but the structure's the same. So what I can also do is I can then also view it as a DIGGS file. So I can actually do that right from here. And then I can save it as the DIGGS structure that you see. You can also see the actual values that GeoZeta contains. This might be something that is a helpful thing, is that you can also see the anticipated values. So like I could come into here and say, what does GeoZeta think that I will have? And so we are training off of all of this data that we're provided, so that we can then predict what you'll have. And so you see it here where it's the flows, the soil types, and the groundwater. Something that we can also do is the anticipated seismic site class. So I think that was mentioned. And so basically this is performing the anticipated drilling, and it is then predicting the range of the possible site classes. Something that we've just started to do is we are now converting all of our PDFs into DIGGS. And these are a huge range of page structures. All right, so that's kind of a quick way for you to see a DIGGS file. Yeah, and for you all to hopefully be able to get started.
So Ross, they can pull individual boring logs down in DIGGS format, right? But if they need a
Yes.
larger group of data points,
You can actually do that right from here. So right from here, if you draw a polygon, you can actually save it as a, if I go into generate views. Oh, actually, I don't have it in here. I can put it in here. Or if you all want to request a region, then we can generate the DIGGS file. Yeah, so great question. Something that we do also do is we provide 3D visualizations of the data. So like in here, you see the DIGGS results. So if I go right into here, then I could save it as the DIGGS file. Awesome. All right. Are there any other questions?
Is there any like documentation on how it's doing the predictions?
Yes, yes, and I'm currently in the process of writing a paper. So basically, we're using a random forest model, and we provide all of the documentation through, if you go to the main page and you go into about, and this is our research and publications page. Great question, and feel free if this is something that you're interested in. I would be glad to talk through it.
Yeah, no, it sounds great. So I guess are all the same people going to be on call tomorrow again, or?
No, so tomorrow's going to be the general kind of people who are interested in using DIGGS. So you'll see the same core group, but the participants will be from DOTs and companies and so on.
I gotcha.
So tomorrow will be the first glimpse at DIGGS 3.0.
Yeah.
Right, Dan?
Oh, poor Dan. I'm sorry, Dan.
I'm giving you a day's warning.
At least you got a warning. Yeah.
It'll be a small glimpse. How's that?
Okay.
Fair.
We don't want to glimpse too much.
Yeah.
We got an interesting presentation, I think, tomorrow morning as well from a company in Australia trying to use this for mineral exploration.
Oh.
So it'll be interesting to see what they're trying to do.
Yeah.
Nick, I think
Sounds
they're
good.
trying to use your database structure.
That's right. Nick's dates to base. Yeah. So that's really, really cool. All right. Awesome. Yeah. Feel free. I think you can feel free to reach out. I'll put my email here. And anyone can feel free to reach out. And you can also put questions in the repo. And we look forward to seeing you hopefully tomorrow and for sure at the next office hours.
Yeah, and if you have questions between now and then, feel free to shoot us an email or something, and we'll try
Yep.
to keep you moving.
Alrighty, sounds great. Thank you.
Thank you.
Thank you.
Thank you.
Bye.